Okay, guys, let's get started. Let's get started. So, a boulder of mass 20 kg and radius 20 centimeters rolls down a hill 15-meter high from rest. What is its angular momentum when it's halfway down the hill at the bottom? Well, we'll just solve one of the problems, okay? So, here's the boulder, and we'll do part B. Okay. The angular momentum at the bottom is I times omega. And for a sphere, the angular momentum about the center of mass, the moment of inertia about the center of mass is, you guys can look this up, 2/5 mr squared. Okay, so and omega is v by r. So omega is the speed at the bottom divided by r, the radius of the boulder. Okay. So again, the way we'll solve this problem is we'll say the initial energy is equal to the final energy. What you have is gravitational potential energy at the initial point, and at the final point all you have is kinetic energy, except that it's kinetic energy of translation plus kinetic energy of rotation. Okay. Okay. mgh equal to 1/2 mv square plus 1/2 I is, okay, I will use the same notation, m. I'm mixing my little r's and big r's. Moment of inertia is 2/5 mr square, and omega square is v square over r square. Again, the mass cancels, so every boulder will be going at the same speed. Okay. All right. Well, I've canceled the mass, but what it's saying is the potential energy got converted to kinetic energy and rotational kinetic energy. Okay. So if this were you multiply this by 10, that would be 5, and that would be 2. So if the rotational kinetic energy is 40% that of the translational kinetic energy. In a disk rolling down in a cylinder, the rotational kinetic energy was 50% of that of translational kinetic energy. So for a boulder, there's less energy in rotational kinetic energy. Anyway. All right, so what are we? Yeah, so H is given, so we can solve for V. GH is okay. Of radius 20 centimeters. Okay, so So that's the angular velocity. Oh, actually, there's a anyway. What is the angular momentum is the question. So angular momentum will calculate it. Oh well. Okay, so there's the angular momentum, and so a 20 kg boulder is a 50-pound boulder, and 15 meters would be roughly the height of this building. So it's rolling down a hill, the height of this building, and that's the angular momentum at the bottom. Okay. Yep.
If you go back one slide, when you're setting the equation equal to velocity, and you have 10 multiplied by GH over 7, on the next piece to the right, that's 9.8 times what?
15. Height is 15.
Height 15. Okay, got it.
All right, any other questions before we move on? Okay, so I only did one part of the problem.